Hiding in the ceiling of most modern classrooms right now is, well, it's a 22-pound fire-resistant web server,
Yeah.
and it is disguised as an everyday paging speaker. Welcome to today's deep dive. We're looking at a technical spec sheet from AV Distributor HDTV Supply, and it's for something called the Advanced Network Devices IPSMOD-IP Speaker Module, which is quite a mouthful.
It is, yeah. And, it sounds like a totally dry piece of hardware at first glance.
Oh, absolutely.
But our mission today is, to look past those sterile bullet points. We're unpacking the hidden technological complexity that's just operating quietly in the background of your everyday campus and, corporate infrastructure.
Right. So let's completely rethink what an overhead speaker actually does, because the old analog versions were, they were essentially dumb water pipes, right?
Exactly. Just audio flowing one way down a copper wire, like directly from the principal's office to the classroom.
Yeah, but looking at this spec sheet, this device is entirely network-based. It's pulling both its data and its power exclusively through a standard Ethernet cable.
Yeah, that's the power over Ethernet, or PoE, feature in action. It's pulling up to 30 watts directly from the network switch.
Wow.
And the immediate benefit here is that a facility doesn't need to hire an electrician, right? You don't have to run dedicated high-voltage power lines to every single speaker in a massive building.
Yeah.
It all just runs safely over standard data cables.
Okay, let's unpack that because it goes way beyond just power. This thing is running on protocols like VoIP and SIP. It even has its own built-in web server,
Yeah, it does.
which is wild. Like, why on earth does a ceiling speaker need its own web server?
Well, because it shifts the speaker from being just a passive output, to an active node on a vast digital grid. What's fascinating here is that using SIP session initiation protocol, it essentially gives this specific speaker its own internal phone number on the network.
Oh, I see.
So instead of blasting an announcement to the entire school or hospital,
Mhm.
an administrator can literally call a specific room directly.
Okay, it's like we upgraded a simple string and tin can directly to a smartphone. That makes perfect sense. It's more like a highly secure postal system than a water pipe.
That's a great analogy, yeah.
Every packet of audio has a specific digital address, a delivery confirmation, and like a priority level. I also noticed it supports DHCP and both IPv4 and IPv6, so it really is functioning as a full-blown computer.
It has to, honestly.
Mm-hmm.
DHCP allows the network to automatically assign it an IP address the very second it's plugged in, making it completely plug and play for IT teams.
Right.
And placing audio on the network like that allows IT departments to manage campus sound systems with the exact same centralized precision they use for routers.
Meaning they can use that web server we mentioned to, what, update firmware?
Exactly. Update firmware, adjust volume limits, run remote health checks to ensure a speaker hasn't failed, all without ever leaving their desk or, climbing a ladder.
Right. But having a sophisticated digital brain is, it's entirely useless if the hardware melts during an actual emergency.
Oh, absolutely.
Because this isn't just a convenience device, it's a life safety tool, which completely explains why this single speaker module weighs a massive 22 pounds.
Yeah, it is incredibly hefty. And that's also why it integrates with software like Clockwise Campus and is InformaCast enabled.
Those are the systems specifically designed to override local audio for mass emergency broadcasts, right?
Right. And to guarantee that critical message gets through, the physical casing is rigorously tested. It's constructed from heavy-duty, flame-retardant, and ignition-resistant plastic.
Okay, here's where it gets really interesting, though, and where I actually want to push back on the spec sheet a bit.
Okay, what did you find?
Well, it explicitly claims this casing makes it suitable for both indoor and outdoor applications.
Hmm.
But right below that, there's a strict warning saying that if you put it outside, you still have to buy a separate weather-resistant enclosure. Why the glaring contradiction?
Yeah, it definitely looks contradictory at first glance, but it actually highlights a crucial distinction in material science and hardware engineering. Well, thermal safety, the ability to resist catching fire or melting during an active emergency, is a completely different challenge than environmental sealing.
Ah.
Environmental sealing is what stops rain, dust, and humidity from corroding the electronics over time.
So it's tough enough to survive a fire, but a rainstorm is just a different kind of threat.
Right, exactly. The strict division in these specs underscores the absolute baseline for a life safety device, which is surviving a catastrophic event long enough to get an evacuation message out. Protecting it from everyday weather is just handled as a separate, secondary layer of defense.
Got it. So what does this all mean for you? The next time you're walking down a hospital corridor or, say, a school hallway and you hear an overhead chime, remember what is actually happening above the ceiling tiles.
Yeah, you aren't just listening to a piece of copper wire.
No. You are listening to a 22-pound, fire-resistant computer node that is actively negotiating with a massive network architecture.
It's pretty incredible when you think about it.
It really is, which leaves me with this thought for you to mull over. If a modern speaker module requires this intense level of digital architecture, specialized software integration, and heavy-duty physical fortification just to broadcast a simple voice message safely,
Yeah.
how incredibly fragile are the older, non-networked communication systems we still blindly rely on every single day?